Esters are characterized by carbon to oxygen double bond and carbon to oxygen single bond and the carbon to hydrogen bond from an sp3 methyl group. Here in our background we have an isopentyl acetate IR. What we can appreciate from here is the C2O, the carbon to oxygen single bond in this stretch, and here the carbon double bond to oxygen stretch, and finally our C2H stretch from the sp3 methyl groups. Esters can be synthesized by organic acid and alcohol. The presence in an ester can be seen by these three stretches from an IR. To see the mechanism behind the synthesis of an ester, we're going to go over the reaction of isopentyl alcohol and glacial acetic acid. Thus, we have glacial acetic acid react with isopentyl alcohol in the presence of sulfuric acid. Glacial acetic acid will be protonated by sulfuric acid. The electrons in this double bond will move towards the oxygen, and these electrons in this oxygen will take up this hydrogen ion. This reaction will give up this intermediate now, and because this oxygen gave away its electrons, it will now be positively charged. This intermediate here contains an oxygen that's positively charged and unstable. Thus, electrons from this double bond will be taken up by this oxygen. Isopentyl alcohol can now act as a nucleophile and attack this carbonyl, this carbon. For simplicity, I will redraw the compound from now on to look like this. In our step 3, we will see the deprotonation in this oxygen of our product. The electrons in this double bond will return to the oxygen, and electrons in this alcohol will take up this proton. These hydroxyl groups can now deprotonate any compound in our solution. The electrons in this double bond will return to the oxygen, while these electrons in this oxygen will take up a hydrogen. There are many compounds in a solution that have hydrogens that can be donated. Our product now contains a positively charged oxygen. The charged oxygen is now a good leaving group. Electrons in this double bond can now return to this oxygen and make water. Simultaneously, we can have a compound in our solution deprotonate this hydrogen here. Electrons in this double bond will return to the oxygen. This reaction will give us the following products. This double bond in our product was made during this step when electrons were returned to our oxygen to compensate for any charges present. Finally, we have our ester or isoamyl acetate or isopentyl acetate. The common names used are banana oil or pear oil. This whole reaction is called the Fischer esterification reaction.